I'm Aki Roberge, an astronomer at NASA's Goddard Space Flight Center. I've been studying a young nearby planetary system around the bright star Beta Pictoris. Located 63 light-years away and only about 20 million years old, the star is surrounded by a vast disk of gas, dust, and comet-like bodies that we view edgewise. We know of one planet in there too. It's a giant planet tracking along an orbit nearly as large as Saturn's. I'm part of a team studying Beta Pic's disk using the ALMA Observatory in Chile. We've found something odd. A belt of carbon monoxide gas centered about 3 times farther from the star than Neptune's distance from the Sun. The total amount of gas is about 1/6 the mass of all the water in Earth's oceans. What's interesting is that incoming ultraviolet light should break up the carbon monoxide molecules in little more than a century on average. This means that the carbon monoxide must be resupplied by the breakup of icy comets. To produce the amount of gas we detect, we're looking at the equivalent of the total destruction of a large comet every 5 minutes. From our data, we can tell that much of the carbon monoxide is in 1 or 2 massive clumps, which was very surprising. Because we're viewing the disk edge-on, we can't be sure if it's 1 or 2. Regardless, the comet supplying the gas must also be concentrated into clumps. How could this happen? If there is 1 clump, we think we're seeing the aftermath of a collision between 2 icy planets about the mass of Mars. Such a collision would have occurred about 500,000 years ago, releasing large quantities of gas and small comet-like fragments. The second, and we think more likely scenario, is that the carbon monoxide exists in 2 clumps and is continually replenished by collisions in huge comet swarms. We believe the comets are shepherded together by an as-yet undetected second planet, whose gravity confines the comets into a small region so they frequently collide. A planet with roughly Saturn's mass could do the job. Other observations hint that the brightest clump is moving in a way that makes the 2-clump scenario more likely. Further observations will track it in better detail and help us confirm this dramatic picture.